Hyperparameters are crucial settings in machine learning models that significantly impact their performance. Unlike model parameters, which are learned during training, hyperparameters are set before the learning process begins. Examples include learning rate, batch size, and the number of layers in a neural network. Proper tuning of these hyperparameters can lead to better model accuracy and efficiency. This presentation will guide you through the process of tuning hyperparameters using Azure Machine Learning, a powerful cloud-based service that simplifies and automates many aspects of machine learning. Hyperparameter tuning is essential because it directly affects the model's ability to generalize from training data to unseen data. Poorly chosen hyperparameters can lead to overfitting or underfitting, resulting in poor model performance. For instance, a high learning rate might cause the model to converge too quickly to a suboptimal solution, while a low learning rate might make the training process excessively slow. Azure Machine Learning provides tools to automate and optimize this tuning process, making it easier to find the best hyperparameters for your model. Azure Machine Learning is a cloud-based service that offers a comprehensive suite of tools for building, training, and deploying machine learning models. It supports various machine learning frameworks like TensorFlow, PyTorch, and scikit-learn. One of its standout features is the ability to automate hyperparameter tuning, which can save data scientists a significant amount of time and computational resources. Azure ML also integrates seamlessly with other Azure services, providing a robust ecosystem for end-to-end machine learning workflows. Before you can start tuning hyperparameters, you need to set up your Azure Machine Learning environment. This involves creating an Azure ML workspace, which serves as the central hub for all your machine learning activities. You'll also need to configure a compute target, which is the hardware resource where your model training and hyperparameter tuning will take place. Azure ML supports various compute targets, including local machines, Azure VMs, and specialized hardware like GPUs and FPGAs. Hyperdrive is Azure Machine Learning's hyperparameter tuning service. It automates the process of exploring different hyperparameter configurations to find the optimal set. Hyperdrive supports various search algorithms, including random search, grid search, and Bayesian optimization. It also allows you to define early termination policies to stop poorly performing runs, thereby saving computational resources. Hyperdrive integrates seamlessly with Azure ML, making it easy to set up and run hyperparameter tuning experiments. To configure a Hyperdrive experiment, you need to define the search space for your hyperparameters, the primary metric to optimize, and the search algorithm to use. The search space can be defined using discrete or continuous distributions, depending on the nature of the hyperparameter. For example, the learning rate might be sampled from a log uniform distribution, while the number of layers could be sampled from a discrete set of values. Once configured, Hyperdrive will automatically explore the search space to find the best hyperparameter settings. Hyperdrive supports several search algorithms, each with its own strengths and weaknesses. Random search randomly samples hyperparameters from the search space and is simple to implement, but may require many trials to find optimal settings. Grid search exhaustively explores all possible combinations of hyperparameters, but can be computationally expensive. Bayesian optimization uses past evaluation results to inform future searches, making it more efficient, but also more complex to set up. Choosing the right algorithm depends on your specific needs and computational resources. Early termination policies in Hyperdrive help to save computational resources by stopping poorly performing runs early. Azure ML supports several types of early termination policies, including bandit, median stopping, and truncation selection. The bandit policy stops runs that are significantly worse than the best runs so far. The median stopping policy stops runs that are worse than the median performance of all runs at a given point. Truncation selection stops a percentage of the worst performing runs at each evaluation interval. These policies can significantly speed up the hyperparameter tuning process. Once your Hyperdrive experiment is running, Azure Machine Learning provides various tools to monitor and analyze the results. The Azure ML Studio interface allows you to track the progress of each run, view logs, and compare performance metrics. You can also use the Azure ML SDK to programmatically access and analyze the results. This helps you understand which hyperparameter settings are performing well and why, enabling you to make informed decisions for further tuning or model adjustments. Let's consider a case study where we tune the hyperparameters of a neural network for image classification. The hyperparameters to tune include the learning rate, batch size, and the number of layers. Using Hyperdrive, we define a search space for each hyperparameter and choose Bayesian optimization as the search algorithm. We also set an early termination policy to stop runs that are not promising. After running the experiment, we analyze the results to find the optimal hyperparameters, which significantly improve the model's accuracy on the validation set. When tuning hyperparameters, it's essential to follow best practices to ensure efficient and effective results. Start with a broad search space to explore a wide range of hyperparameter values. Use early termination policies to save computational resources. Choose the right search algorithm based on your specific needs and constraints. Monitor the tuning process closely to identify any issues early. Finally, validate the tuned hyperparameters on a separate test set to ensure they generalize well to unseen data. Following these best practices can help you achieve optimal model performance with minimal effort. Azure Machine Learning integrates seamlessly with other Azure services, providing a robust ecosystem for end-to-end machine learning workflows. For example, you can use Azure Data Lake for data storage, Azure Databricks for data preprocessing, and Azure DevOps for CI/CD pipelines. These integrations make it easier to manage the entire machine learning lifecycle, from data ingestion and preprocessing to model training, hyperparameter tuning, and deployment. Leveraging these integrations can help you build more efficient and scalable machine learning solutions. Hyperparameter tuning is a critical step in the machine learning process, and Azure Machine Learning provides powerful tools to automate and optimize this task. By leveraging Hyperdrive and other Azure ML features, you can efficiently explore different hyperparameter configurations to find the best settings for your model. As a next step, consider experimenting with different search algorithms and early termination policies to see how they impact your results. Additionally, explore other Azure services to build a comprehensive end-to-end machine learning workflow. With these tools and techniques, you'll be well equipped to tackle even the most challenging machine learning problems.